Hello, good morning, good your time zone. Morning to me, although it's pretty dark out there and pretty rainy. Could be nighttime, I would believe it. This isn't a usual streaming time on my current schedule, but I got nerd sniped. Nerd sniping being where somebody interests you in solving a problem and now you can't put it back down. I was idly leafing through LinkedIn, drinking my morning coffee, and I saw this post by Laurent Bossavy, and he's a technical coach, etc., technical advisor and coach. I'm lightly acquainted with him, but that's about it. And he works on the kind of stuff that I work on as well. So professionally, we are for sure acquainted. And this note was in French, and sometimes I will go to the trouble to work through it. I definitely caught the first part. Tonight I have a dojo. This evening I have a dojo. Programming dojo, of course. Do you want to come? I can propose, I have a kata to propose to you. Uh, t'entraîner and entraîner for learning, maybe? Um, yeah, and then around this point, I thought I'm going to stop struggling through the French and let LinkedIn translate it for me. So here we are. Translation is tonight I have dojo, programming dojo, to train, entraîner. Okay. Yeah, he's trying to get back into some programming too. So he has a vintage subject. It's an old exercise. And what caught my interest in particular, this is the problem that we're going to work on. Um, what caught my interest is that there was a Knuth solution that was already published years ago that I'm not going to look at, and there was a McElroy solution, and I immediately thought I want to work on what was probably the McElroy solution. So he invented pipes. Pipes are where, for example, where do I have some interesting files? In here, I have some files. And then I could, a lot of them have a .local in the name, so I could strip that off with a sed command that looks for .local and end of string and replaces it with nothing. And now I start to have some text that I have done that to, and then say you want it, I don't know, sorted in reverse order, for example. Um, so these are examples of pipes. With each pipe, you can further modify the output from the previous and make that the input to the next. And Doug McElroy invented that. It's an unbelievable productivity boon, and kind of Unix's native version of functional programming. That everything comes out of one and into another, and the stream format is plain text in the usual case. These are called filters. So I saw that there was a Knuth solution, which is probably nothing that I would be capable of coming up with. Uh, and then there's a McElroy solution, which is pipe things together. I'm guessing that's what he would have done. I don't know. But so it caught my attention, and this was just a few minutes ago, and I thought, well, I have time. I'm going to work on this. I might as well stream it. So that's why we're on today. Um, so let's look at the problem statement that's right here. With an integer k as input and a file containing text, for output, display the k most common words in the text, along with the number of occurrences in descending order of the occurrences. So I think to begin with, I need a file containing some text. Lorem ipsum generator. I hope it'll repeat some words so that we can count them differently. Yeah, 5 paragraphs. Yeah, I see some repeats. Dolore, dolore. Okay, generate. Copy. And then here I am in my nerd snipe directory. I'm going to pb paste that into the text. And there it is. Okay, so we have some text. That's a file containing text. And then we want an integer k as input. So for example, 5. Then we're going to display the 5 most common words in the text. along with the number of occurrences in descending order, so most first. So the first thing I need is what are all the words in the text. And I feel pretty sure that splitting on white space is probably good enough for a first pass at this problem. So a lot of ways I could think to do that, but what I'm thinking now is there might be a Unix tool that I don't know about yet that does this really well. Unix split text into words. Okay, I have another idea, and that is that I can just use sed, probably. So if I replace every occurrence of a regular literal space with a new line, and do that globally every time, what does that give me? That's decent. Okay. And then what else about that? Uh, I think the original file is maybe missing a new line at the end. Let's try that again. Yeah, now that looks less funny at the end. Okay, so this is approximately a list of words. One thing I can see about it is that there are dots at the end of some of them, and probably commas at the end of some of them. And then there are some blank lines. So first let's chop out the blank lines with a grep, an inverse grep, a line that consists solely of a beginning of line marker and an end of line marker. Don't show. And that should make a difference. Okay, the next thing we need is to strip off trailing dots. And then again, that can be a sed, that there's a literal dot at the end of a line, at the end of a string. And that should take care of that. Then we have case differences. So like some uppercase, some lowercase, and presumably we should be counting those case insensitively. So one easy way to make that possible is to lowercase all the words. Is there? I feel like there's, no, there's, I think that's with TR, if I'm not mistaken. I think that's the easiest way to translate from one character class to another character class. That seems to have done it. So these are all things that I'm right on the edge of needing to look up, but if I've used them recently enough, then I don't have to. Um, okay, so we're getting incrementally somewhere. Let's pipe this through less and see if there's any funny stuff. Yeah, we do have trailing commas, so we do need to do that too. Um, could probably do that with the same set expression, but I could also just do it with one more set expression, which has the chance of being more readable over time in the event that there was time as a factor in the software. Yeah, so take out commas at the end of a line. And now we don't have those. Okay. So those are probably all the words in the file. I feel pretty good about that. Let's see if there's anything with a space in it. There's not. Uh, let's see if there's anything. Yeah, there's no space whatsoever in it. Okay, so then these pretty substantially are all the words. Now I want to, what was the challenge? The k most common words with the number of occurrences in descending order of these occurrences. So one thing I can do is sort this. which doesn't change anything about which words are in it. And then I can unique dash C that, which will, given words that are next to each other, collapse them into a count. So here I have number of occurrences and word. And now if I sort that in reverse numerical order, I got what's being asked for almost. And then if I do a head, say the number was 5, and that's our answer. So what's left is to take the input and then maybe make this program a little better self-describing. And so what I'm going to do now is copy this into a solution program, paste that in there, make it executable, and get the same result. Okay, so I have placed that there. Next thing I would like to do is give this program a slight bit of structure because shell scripts are not obligated to, but I find it very helpful to get a control flow at a glance. So here's one. This should also work the same, and it does. And then the next thing I would say to make this more readable is to chop up this very long line. So let's do that. I guess everywhere I have a pipe. No, everywhere I have probably a space, pipe space. I want to replace that with a backslash and a new line. Okay, and again, still works. Next thing I want to do is probably take the text as input, which is as simple as not passing it. And then I do it like so. And then if I give it different text, I get a different output. Let's rename this. We're going to call it K most common words. K most common words in the text are those. Next, I want to take some kind of way what the number should be. So let's say we do it like this. K equals the first argument. And we'll substitute it there. So now I can't just say this. I have to say, let's say the 10 most common. There they are. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so I feel pretty good about this solution for purposes of the answer and what it looks like. Is there any refactoring we might want to do? I think formatting, I think I prefer this a little bit. So white space to new line. What we could do, I'll do one more thing. So I'm fairly conversant with these Unix utilities, as you saw by me composing them this way. But that doesn't mean, especially in the regular expression cases, it doesn't mean we can't describe them better. And I would like to. So let's say uh, spaces to new lines is going to be a function. And I'm going to extract this. Then we're going to call spaces to new lines. And that should work equally well. And it does. So let's carry on that way. The next thing is remove blank lines. That's this one. and again, works. That's funny. Sed is one of the most common words, and it's one of the most common utilities used in the solution as well. Okay. You know what? Let's call this spaces 2 new lines. That's a little more humane. Then I have a couple set expressions, one of which takes out trailing dots, one of which takes out trailing commas. Move trailing dots. Remove trailing commas. That's this one. That's this one. And again, those, I'm very sure that we could write a single regular expression to do both of those, but I'd rather not, unless there's some specific performance need to do so. Remove trailing dots. Remove trailing commas. Again, works just as well. Um, and then this is lowercase. Convert to lowercase. And that's this. Oops. Sort, I think, might not necessitate uh, any clarification. I think that's clear enough. And then um, count occurrences. What this is for. And that be the best possible name. Could be more precise. Like list occurrences with leading number or something, but that's going to get clear in a second, I think. Sort most occurrences first. And show only first K lines. That way, if you don't know these Unix utilities, you can come to know and you can follow the flow anyway. Yeah. So the way this would work would be that we would call show only first K lines and just pass that as the parameter. And then this would just be the same again. So I made a bunch of changes, but I'm fairly confident that this is not broken, and it's not. So again, I could say 20, and I could do it on a different text. Let's get 80 paragraphs. Giant text. And we'll get the 10 most common words in giant text. There are different words and there are a lot more counts. So I feel like this is a good enough solution that my nerd snipe need has been satisfied. What we did, just to recap, this is a very short stream, is incrementally using Unix pipelines and Unix tools, uh, solve this problem, which admits a number of solutions, I'm sure, but this is the one that's most native to me. Given a file with a bunch of words in it, someone asks you for the N or the K most common words. Show those with the number of occurrences most first. And this is how we did it. And I think even though this is a shell script, I think somebody who isn't me and comes to this program would understand the mechanics by which we arrived at the answer. And if they discovered anything new that needed to be cleaned up in the input, I think they could see how to do it. So I'm pretty happy with this. I didn't have to program very hard. I just had to try stuff until I had the answer using existing tools. So I'm going to stop here, and then I'm going to post this video on the LinkedIn thread. So again, this was due to a LinkedIn post from Laurent Bossavi, and it was a little dojo, and I have just done the dojo enough to my taste. So thanks for watching this unscheduled stream. Nice to have you. See you at our regularly scheduled stream on Monday.